चैनल भी बिलोंग में सभी स्वागत है। आज हम पढ़ाने जा रहे हैं वर्नर थ्योरी ऑफ कोऑर्डिनेशन का पार्ट। मेन पोस्टुलेट ऑफ थ्योरी आर एज फॉलो। मेटल possesses two types of valency termed primary or principal valence, secondary or non-ionizable valency. Primary valency is referred as oxidation and primary valency are those which a metal exhibits in the formation of its simple salt. Thus, in the formation of PtCl4, CuCl2, CuSO4, AgCl, the primary valency of it are 4321 Pt, Co, Cu, and Ag. The secondary valency is termed a coordination number of the metal cation. Secondary valencies are those which a metal atom or cation exercises towards ligand in the formation of complex ion. Every metal cation has a fixed number of secondary valency. In PtNH3 whole 6 Cl4, CuNH3 whole 6 Cl2, CuNH3 whole 4 SO4, AgNH3 whole 2 Cl. The secondary valency are 6 for Pt plus, for Cu plus, 4 for Cu2 plus, and 2 for Ag plus respectively. The second point, every metal atom has a tendency to satisfy both its primary and secondary valencies. Primary valency are satisfied by negative ion, whereas secondary valency are satisfied ligand. Third, the ligand satisfying secondary valency are always directed toward fixed position in space due to the directional nature of coordinate covalent bond present between ligand and the central metal ion. Secondary valency thereby give rise to a different geometry of the complex. However, the primary valency are non-directional due to ionic nature of interaction. When the coordination is fixed, the secondary valency are directed toward the vertices of regular octahedron about the metal ion. Fourth, primary valency is ionizable, while secondary valency is non-ionizable. For example, when CuNH3 although BrCl is allowed to react with AgNO3, it gives a precipitate of AgCl and not AgBr. It means that Cl minus, which is satisfying primary valency, is ionizable, and Br, which is satisfying secondary valency, does not ionize. Valence bond theory. This theory was proposed by Linus Pauling. According to this theory, the structure of the complexes can be explained on the basis of hybridization. Orbitals of central metal atom or ion hybridize according to number of ligands approaching each ligand coordinates a pair of electrons through coordinate covalent bonds. These pairs of are accommodated in the vacant orbitals of the metal atom or ion in complex sp3, dsp2, d2, sp3, sp3 due to both require hybridization will come some silent feature of PVT as follows. First, in this approach, a basic assumption made is that the metal ligand interaction arises by the donation of pair of electrons by ligand to the metal atom or ion through coordinate covalent or dative bond. In order to accommodate these electrons, the metal atom or ion must possess requisite number of vacant d orbitals of comparable energy. These orbitals of metal atom ion undergo hybridization to give a set of hybrid orbitals of equal energy depending upon the number of ligand approaching. Metal orbitals are vacated and made available for hybridization in filling electrons in the complex molecule. Hund's rule of maximum multiplicity is followed. Moreover, under the influence of strong ligands, the metal electrons are forced to pair up. Contrary to Hund's rule, sometimes the unpaired n-1d electron pair up as per the need prior to the bond formation, thus making some n-1d orbital the central atom that makes available a number of empty hybrid orbitals for the formation of coordinate bond with suitable ligand orbitals. With the approach of ligand, metal ligand bonds are formed by the overlap of these hybrid orbitals with those of the ligand. A substance which do not contain any unpaired electron is not attracted by magnet, it is said to be diamagnetic. On the other hand, a substance which contains one or more unpaired electrons in the d orbital are attracted by magnetic field, it is said to be paramagnetic. The magnetic moment is a mathematical parameter to express the paramagnetism of the composed. It can be calculated by b equal to n plus 2 root magnetic moment in the Wehrmacht and the number of unpaired electrons. Octahedral square planar and tetrahedral complexes are formed as a result of d2 sp3, sp3 d2, dsp2, and sp3 hybridization respectively. Cause of lengthened contraction. The lengthened contraction, although more pronounced, is similar to the contraction that was encountered in transition metal. Then the cause is also the same in both cases as we move through the lengthened ship. Force of electrons are being added one at each step. The mutual shielding effect of the electron is substantially little bit being even smaller than that of the orbital. This is due to the f orbital. The nuclear charge, however, increased by one at each step. Hence, the inward pull experienced by the 4f electron increases the sum of successive directions gives the total and the net contraction. It may be noted that the decrease in size, although continuous, is not regular. The decrease is much more in the case of first six element that in case of subsequent element. Consequences of the thread contraction. Lengthened contraction is an important factor in allowing the separation of lengthened from one another. Not only that, lengthened contraction has a highly significant effect on the relative properties of the elements which precede and follow the lanthanoids. In the periodic table, the radius of LSD, for example, is 0.21 angstrom than that of Y3 plus Y ion, which lie between HR and HF. The atomic radius HF4 plus should have green greater than that of the ZR plus, which lie immediately above it by about 0.2 angstrom, but the occurrence of lanthanide contraction of about some order almost exactly cancel the expected increase. The result is that HF4 plus and GR4 ions have the same almost identical radii, identical chemical property being 0.80 angstrom and 0.81 angstrom respectively. Zirconium and hafnium have therefore almost identical chemical properties as the radii are very similar, even though the number of electrons increases from 42 to 72 and the atomic mass increases from 91.22 to 170.9 gram per mole. The increase in mass and the unchanged radii lead to a steep increase in the density from 6.51 13.356 gram per centimeter. Radii dependent property such as addition, dispersion and stability constants are also similar. धन्यवाद दोस्तों, यहीं पर ख़त्म करते हैं। चैनल को लाइक सब्सक्राइब शेयर करना मत भूलिएगा। धन्यवाद दोस्तों।